good to be here today. Thank you very much for your time. And my name is Drew Decker. I'm a National Map Liaison with the U.S. Geological Survey. So being a liaison means I work with folks on cooperative base mapping projects, such as layers as elevation, hydrography now, and other data sets as well. But those are the primary two. So I cover several states, based in California and San Diego. And I also cover, in addition to Hawaii, I cover Oregon and Washington as well. So thanks again for your time, like I said. And what I'm going to do today is go through some slides. I'll go through them fairly rapidly. And the intent here is to try to give you some information on what we call the 3D NTM, 3D National Terrain Model, which is sort of now the combining of elevation data with hydrography. We've long had hydro data available through the NHD, National Hydrography Data Set, but now we're going to be generating new and totally new data for hydro out of the LiDAR. Okay, so it's kind of a new approach to what we had done before in the past. And so what I'll try to do is to show you kind of how that works. And again, as Arthur was saying, we have the DCA, which is a new vehicle for partnering with USGS. So what I'll do is go ahead and get my thing set here. Okay, are you able to see my title screen now?
Yes. Yes, you can see it.
Okay, wonderful. Okay, so thanks again for your time. And what I'm going to do is start with the National Topography Model 3D NTM first. So I will talk a little bit about 3DEP, 3DHP, and then the DCA agreements vehicle that we have. So, okay, 3DEP is recap. Everyone's probably familiar with it. 3D elevation program. The goal of this is to complete acquisition of national LiDAR with IFSAR up in Alaska. It's kind of our first ever national baseline of high resolution elevation data. We're pretty close to that now and have another map on the next slide that'll show that in a different degree of detail. So what we did was we commissioned a study, or conducted a study, I should say, 2011, way back when this started, called the National Enhanced Elevation Assessment, or NEA. And we used that to get information on the requirements for 3D elevation data. Who's going to use it? What are the benefits? How would it be applied, for example? And so now, a number of years later, we're almost done. So we're on track to complete the baseline by the end of this fiscal year 26, actually. So maybe a year from now. There are a few projects that still need to be completed here or there. You can see some of the statistics on the left. Number of partner organizations, including State of Hawaii, Hawaii County, okay, other groups, number of points, et cetera. And you can see the country fill in with the different projects that we collected the data. So what we brought to the table with this was kind of an operational infrastructure, allowing us to work with folks on these projects. We have the data collaboration, more on that in a second. We have the geospatial products and services contract. So these are contractors who are pre-approved to be able to make the products that we need done, both elevation data and hydrography data. We have the U.S. Interagency Elevation Inventory, which we work with NOAA on that, and that provides information on all the discoverable LiDAR out there. We have LiDAR base specifications. We have the national map, which distributes all of the data so that other organizations don't have to do that. And we have the LiDAR Explorer application, allowing people to process LiDAR data within the cloud and view the point clouds as well. We have a LiDAR base specification, which is updated frequently. I'd say about once a year or so. This provides information, again, needed to define the quality level. What are the accuracy requirements? What's the classification of the LiDAR point cloud, for example? So you can get the current spec here at that link, plus all of the previous specifications as well. LiDAR quality levels. Quality levels 1 and 2 are defined as meeting our specifications. A minimum of 2 points per square meter, vertical RMSEZ of 10 centimeters. So we have to have that in order to have it qualified to be a 3-dep product. There's also a QL0 out there, which what that does is tightens up the vertical accuracy even more to 5 centimeters. There are a few QL0 projects out there, but not many. The work done to date for Hawaii, by the way, has been QL1. With some older QL2, I believe that was pre-3-dep. And I'll point that out in a minute here. So looking at prior LiDAR collected in Hawaii, where USGS was involved, looking at 2012, there was an Oahu coverage that was done with NOAA and USGS. It's QL2, kind of just before 3-dep got started. In 2018, we started the Big Island collection, and that was the QL1. Started as 2, but became 1. You see the partners here: Hawaii County, FEMA, both the region and headquarters, NRCS, NOAA, a couple different components from USGS. So in 2019, we had Kauai topography. It's still in work. That's the only topography we did here, but we're hoping it'll be done well soon. And FEMA was the partner with that. In 2019, we had the Big Island Kilauea eruptions LiDAR that was collected. That was a QL12. USGS did that, but it wasn't 3-dep. It was using our contractors, but I believe other funds in the USGS paid for that. Then in 2020, we had the Oahu Maui QL1 project. You can see the partners here: Office of Planning, NOAA, NRCS, FEMA, National Fish and Wildlife Foundation, USGS. And then finally, NIHAO, topography, which collected the coastline bathymetric data, and the shoreline of the island of NIHAO was collected by NOAA, their National Geodetic Survey. So putting these all together, you can see the map here showing what's been collected. It's not complete coverage, obviously. So, but you can see this is what we were able to do within the funding and the tasking and the times available. So I think there'll be future LiDAR in work for Hawaii, both to fill in gaps, also recollect data that may be necessary here or there. And so that's something that will become part of this, hopefully, in the not too distant future. Accessing the data, I mentioned the 3-dep LiDAR Explorer. This is a website that we have that allows people to select LiDAR to view. The Hawaii data should be in here. You can zoom in and look at the point cloud data, look at it in the 3D type of view. So this picture on the right there showing the USGS headquarters among all the trees in the Northern Virginia area. And so looking sort of now towards the future of this, we had the 3D Nation Elevation Requirements and Benefits Study. This was done with NOAA and USGS working together on a larger version of the old NIA study. Okay, it had a whole lot of mission critical requirements. I think there's like 1,300 different ways that the data were used or grouped together, individual cases that were put together. You can see a number of federal agencies and state, local, tribal governments as well. And so we're using this to kind of reestablish the need for 3-dep and how can it be improved. So we're wrapping up the baseline, and you can see the next generation of 3-dep. And I've got a little table that'll show that. And the 3D Nation elevation study is available online for download too. And so looking at this a bit just around the corner, as it says, potential multimodal approach. So everything we had was collected airborne, right? Helicopter, perhaps in a few instances, but almost exclusively in light aircraft. But we can also look at some of the other methods here. Maybe there are ways to employ drones, ground-based surveys, even satellite-based. We've seen that used for digital surface models. And so that's something to consider on planning future work in Hawaii and elsewhere. So you're putting this together. We're moving now from baseline to next generation. Before, we used to work primarily in QL2, and the partners helped us upgrade it to QL1 like we did in Hawaii too. Next gen 3DEP lets us work more in Hawaii on the QL1 level. Okay, so starting with a collection density of 8 points per square meter, we'll be able to partner directly with that. The scope has changed too. Used to be topographic data only. Now we have topographic and bathymetric data. It could be near shore, it could be inland as well. Update frequency was 8 years. It's been moved up to 5 years, continental United States, 8 years, Alaska, Hawaii, and the territories. I would hope that we'd be able to go a little quicker than that too, since we have data in Hawaii that's getting older as well. Annual costs go up, but again, you're getting a higher quality product now. Annual benefits go up as well. Inland bathymetry, we're getting more and more of that collected now. Lakes and rivers, just a few of the examples that we have here, the Potomac, et cetera, Klamath. And now in Washington and Oregon, there's a fair amount of inland bathing being collected. And finally, one thing we are putting together is a seamless 1 meter digital elevation model. A lot of our DEM data come out at either 1 meter or even a half meter, but we're generating a 1 meter resolution seamless in 10-kilometer grids that will help us a lot in having the data all put together and merged and matched so that it'll better support the hydrography data development. So that brings us now to 3D National Topography Model. Okay, so it integrates USGS elevation hydrography data sets to kind of model nation's topography in 3D. So on land, underwater, okay, near shore as well, although that's more of a NOAA's contribution there. So it merges the terrestrial component now, right, with the bathymetric and near shore data. It was going to be kind of a seamless terrain model. So the components here really are, we're adding one now, the 3D hydrography program. You see that on the left. It's hydrography derived from and integrated with the 3D elevation program data. We hope it will provide better connections to groundwater, wetlands, engineered hydrography such as stormwater, 3D HP infrastructure in this case, for data sharing as part of the Internet of Water. I'll have a little bit more on that. On the right, you see next generation 3DEP continues with the higher quality levels as mentioned, inland bathymetry. Oops, just went forward. There we go. And continued improvement with new technologies and approaches, as I had on the other graphic there. And then we'll have kind of a future integrated 3D model here shown in that little diagram. Okay, fully integrate 3D HP and 3DEP. So looking at 3D HP now, this is going to be generating new surface water, which is channels and water bodies from elevation. Okay, what we do is we have new specifications for this, telling people, be it contractors or other partners, on how to collect the data, or really what to collect more so than how. The data, for the most part, are often collected by private sector contractors. And we will also have a workflow for contributed data too. If somebody has data they have already obtained from elevation, we might be able to import it into 3D HP. And when the data are developed, just like with LiDAR, we're going to have validation correction cycles until approved for publication. The data may get sent back to the provider for fixing. Once that's done, though, the data you can go back more than once, but hopefully the sooner the better. It gets published and it's approved for publication and it's placed online and shared with our partners too. Okay, specifications, they guide the hydrography collection and validation. USGS has published specifications that guide the collection and validation of the new data. So these resources already exist and are available to the public. I believe it's called 2024 Revision A. It's a current version of the specifications. Okay, and you can see some of the products or the publications on the left and right there, the read rules and elevation drive hydro acquisition specs. We have resources here to click on these. You can see the resource library. We have some interesting error networks or error and topology error examples on there and things like that. Kind of tools that can show the data, information about it. There's a help guide checklist for hydro features, and again, all the rules and relative positional accuracy, quality control. So that's a big deal now because we're using a very high resolution in general elevation surface. So we expect the hydrography to behave that way too, i.e. with monotonicity where everything is headed downstream, not upstream at all, and to have the true flow through this. Okay. Oh, and a couple examples here of what we're looking for. You can see here having a conduit right underneath a roadbed where it needs to go and connect with the lines and things like that. Examples of how we expect the data to be. Hydrography specifications. Okay, they tell the different steps in general. Cleaning and converting, extract the data, you load it up, you conflate it. That is, we have the older NHD data and it conflates the vector data, or I should say the attribute information onto the new product. And we have flow network derivatives and then the catchments. Catchments are very small watersheds that are tied to an individual stream segment. So some of the steps that we go through here. Hydro specs again. We can kind of skip that. Here's a little picture that shows kind of the data up close. You can see the legend on the right. These are the different features now in 3D-HP. It's going to be simpler, by the way, than the old NHD. Old NHD had a lot of other things that we're not carrying on anymore, such as reservoirs versus a lake. It had different types of pipelines and things like that. It even had a swimming pool category, which we don't need anymore. So basic elements like this. Okay. Project specifications. You can go here to the site to get them. Okay. There's a 3D-HP all map service, so that's going to be interesting. I can say a little bit more about that in a moment. What it does is combine really NHD and 3D-HP. We're starting with the national data set of NHD that we have, right? It's complete for the nation. And we're replacing the old NHD with the new 3D-HP as it's developed. So we don't have many watersheds like that, but we're starting to swap things out, especially some up in Alaska, one in Pennsylvania, Tennessee, and there are others on the way. So that's a little map service again that people can add to your GIS. There it is, 3D-HP all. The resources here, data dictionary, and again, from the URL up there at the top. Delivering 3D-HP, these is product specifications, some of the tables that we have with this, different flow lines, hydro locations, okay, drainage area, water bodies, catchments. Okay. Information on that, again, it's part of the specifications. You can visit the website to learn more. 3D-HP design leverages terrain and flow characteristics inherent in the derived hydro, and it improves the hydro modeling for analysis. Okay, it enables network navigation, persistent hydro indexing, such as hydrographic addressing and data sharing too. Important attribute here is a main stem identifier called main stem ID that comes from a main stem implementation of catchment and flow path concepts. There's one major stem identifying a stream from start to finish, and with a single main stem, a single outlet, one headwater source. And from there, we identify drainage basins, the dendritic network associated with it, et cetera. And you have there are some tools for this. You can see the link at the top there, allowing some background information on this through the geoconnects.us site. The hydroclimate data retriever, or HydRiver, is a suite of Python packages and API that can be used for retrieving data from web services. Okay, so users can address or index their data to the 3D HP network to complete and spatially join attribution, showing some of the different features here, the watershed outline, point data, linear data altogether. That's here you've tied now dams and gauges to the watershed. Okay. We also can add addressing to this. There's addressing tools that we can use. USGS has a hydrographic addressing tool called HydroAdd. We have a HydroAdd 2D. Now it's going to be a 3D with a new 3D HP. 3D HP design, again, go a little quicker here. It's based again on the elevation, so it's going to be really tight to the surface here, and the flow characteristic which match what you're seeing on on the ground. It's going to improve hydrologic modeling a lot, enable network navigation, again, persistent hydrologic indexing or addressing. So we'll have a new addressing tool, 3D HP, I'm sorry, HydroAdd 3D, hopefully out towards the end of this year or so for points. Okay, and the little question is how will people be applying it here? I look forward to getting more of this out on the landscape. So the accessing the 3D HP data products gives you information where to find it, websites that we have, the National Map Viewer. There's a lot of stuff in there. We're going to have an annual release of the data, so there'll be a static release every year as we move to replace the NHD with the 3D HP. Okay, moving now, whoops. Okay, there we go. Data collaboration, moving to the DCA. So both of these products are serviced by the digital or the data collaboration announcement, DCA. Okay, so this covers both products, and you can see the little link there, and it takes you to the current DCA. It comes out once a year for every fiscal year. So we have a new one out now, as a matter of fact, for fiscal year 26. And again, it will let you work with USGS and other federal agencies on both products. Okay. So looking at the collaboration, the primary mechanism or vehicle for partnering with USGS and other federal agencies, USGS Digital Geospatial Products and Services Contract, or GPSC, is one way where you use our contractors, or you could apply for a cooperative agreement. What that means is that USGS and the program would give the partner money, and then they would manage the project. They may have their own contractor do the work, for example. And so the DCA project submissions are reviewed against several evaluation considerations, such as is the data already done? What is the priority of a certain region for various federal agencies? So this is just example showing some of the fiscal year 25 high priority acquisition areas. Doesn't mean there's data being done there, but it shows where there was some interest in that. So looking at the different steps here. Oh, and by the way, it used to be called the Broad Agency Announcement for LIDAR BAA. State of Hawaii used that, right, for the Maui project, used the BA before. So it's open to federal agencies, state and local governments, tribal governments, academic institutions, and private sector. And applicants are encouraged to build funding coalitions to pull resources to fund 50% or more of the project costs. And that 50% just applies to the USGS contribution. So other federal money in there could push it past that in some cases. So we provide matching funds to cover remaining costs. So again, you can see the data acquisition steps in the little graphic on the right. The DCA timeline. This is, again, like I said, it's an annual operation here. This is showing fiscal year 24, this whole graphic, but it still holds now. The DCA is typically released in, it says September here, if you look at the left, but it often comes out in August. And this year it is out now. And it's open for the majority of the fiscal year. So if it opens in August, you can put in project submissions usually through June of the following year, and we'll look at them at any time. We do have an early look at the DCA submissions so that awards can be made earlier in the fiscal year if projects need to be collected sooner rather than later. And that's especially important for some of the LiDAR collections, if you want to collect in wintertime, for example. And the first look at this is going to be September 12th, I think, of this year. But again, the DCA remains open for new projects throughout the rest of this calendar year and well into next year too. And you can see here, you can see my cursor, USGS manages the project for GPSC, then partners would provide money to USGS. We would do the work of program management. Or if we have a cooperative agreement, the partner manages it and funding comes to them from USGS. There are different deadlines for getting these things put together. The most important thing, up early at least, is getting funding solidified through an agreement, whether it's from USGS or from the partner, and try to get the projects awarded after we have the agreements signed, and then the work gets underway. So, and again, it repeats. Next year, the new DCA we released, more DCA submissions, et cetera. And so we plan on that happening next year as well, as it had ever since we started the BAA. So people work with liaisons such as myself, and there are a number of us scattered around the country. And so we work with partners on this, both for planning the collection. We can help plan it. What do you want to collect, when and where? What kind of specifications do you want, et cetera? So we can certainly help with that. And then I think that's about it. And we have this little, there's my email address there. And you can see this little 3D image showing 3D HP-like data here. So, and I think that is about it. Are there any questions?
Hi, Drew. Garrett Johnson from County of Kauai.
Yes.
I just have a quick question. So you said about every 8 years capture. So is that from the delivery date or maybe the start? I'm just wondering because it showed the Kauai started in 2019. Would we be waiting 8 years from maybe this year when it delivers at the end of the year?
No, we certainly would hope not. The 8 years to be between different starts of different projects. So
Okay.
if a project started today, you could start another one, say, in 8 years. Okay. I think there's leeway with this too. It could be sooner than that. And so that's not fixed at all. I have seen projects where it starts, several years after each other. It kind of depends on the need and interest in an area. So yeah, and we know that the Hawaii data collection for LiDAR has been lengthy. So we look forward to working with the state and the counties on planning some new LiDAR too. So perhaps collected differently than before. So we want to look at that for planning.
Great, thank you.
Yeah, I think this is Arthur. On your chart, you showed the 2020 Oahu and Maui collections. Well, it dated 2020. I think that was when that BAA was, or when that when that proposal was approved.
Yep.
It actually just wrapped up this year. 2025 is the final.
Yeah, you're
Oh.
talking about the Maui and Oahu. Yes, it did.
So
Some
yeah, I mean the actual collection can take a while depending on weather, and in
can.
that case too, we had COVID to deal with, so that was an extra
Yeah,
wrench.
it was tough for collecting in Hawaii due to the like you said, you had COVID in there. You had the need to ferry aircraft from the mainland and things like that. And so lessons to be learned, I believe, have been learned, I hope, for collections next time. So yeah, it did take a while for that. And I really want to see Kauai data out, ASAP. The data were returned again to us on the 18th of August. And so we're reviewing it now. The turnaround's not supposed to exceed 30 days. So I'm hoping within a couple of weeks, knock on wood, it finally may get the green light here. It'll be done. So I hope so. But yeah, I think I'm glad to have this other work almost done here. And so we can start looking at both maybe some 3D HP in the future. We do try to collect that data via watershed, typically a Huck 8, or it may just be the whole island, depending on the region and of interest here in Hawaii. And but that will be interesting to try some of that, depending on the region you want to collect first, as well as considering new LiDAR too, to both finish the state and perhaps collect data differently where we've learned from the past collections. Oh, stop my sharing here. There we go. And
I have several questions, and I don't want to take over.
Oh, sure.
So the first one is probably fairly easy. So the Oahu LiDAR was 2012 at level 2, and then at 220 at level 1.
Mhm.
When you're creating the seamless, are you and they have different blank spots where they're missing because of the mountains and the flight paths. Would the combined seamless include the 2012, or would it just be the new?
It can. It is designed to take in data from different projects, okay, as need be.
And
in
they
this
don't have to
case,
be the same level.
No, they don't have to be. There is a layering and preference for this, right? It's QL1 versus 2, the age of it as well. There's a pretty complex mechanism for weighting everything and arranging everything and organizing and layering it too. So in this case, you might find that a lot of the areas missed in 2012 are pretty similar to the ones missed in 2020 too, the highest mountains. But there certainly is going to be some spots where you have data that was collected by one project and not the other along the edges of it.
Definitely.
Another question?
Yeah, but I don't want to, if anyone else has some, I have a few. Okay. So FEMA just redid the floodplains for Oahu, and that they've released it for public comment, and it probably will go into effect in 2026, we're expecting. And they used the 2012 LiDAR because that's what they had. And I just wanted to know if they are going to be included, since they do have an important hydrographic value added. Are they part of your cooperative?
FEMA, you mean?
FEMA, yeah, for the flood maps.
Yes. FEMA will do the flood mapping. We don't do that. Okay. But they'll hopefully use the data that we have here. And FEMA has been a partner in this. So they've been a partner all throughout the country, a lot here in California. They also help cover the Big Island project where that got going, as well as Kauai too. So they'll be involved with that. They'll know all about the data, and they'll get the latest data. They've got the latest data, the 2020 data. Was also preliminary data, by the way, that we produce with these projects for LiDAR, and they have that as well. They got that for Kauai, and the final data, they'll get that once it's done. So they're very involved with this too.
Third question is, we have the state DLNR has, I believe they're the authors of a layer that has Hawaiian names for streams.
Okay.
And those are not always the same as the English names, but Arthur may know more about this than I do. Is there any, I mean, you're talking about hydro addressing, so I'm curious whether indigenous names are considered.
In this case, it would be addressed probably to the main SIM ID. There'll be a numerical code for each of the water segments. So things that are addressed to it, it would be like a numerical address on a street. And so, and instead of a street name, you would have probably the code, or the creek name, for example. You probably have the code of the line, right, as what it hooks up to. But it'll still be the same feature. Note though that I'm glad you mentioned that, because we do include names. We have a geographic names information system, and so we use that like on our printed maps too, to print and draw the stream on there and give it its proper name. And we could look into that for you. There are processes for that. You know, as Arthur, I'm sure, is familiar with that. And we have worked with the geographic names information system on our side here on updating names and replacing them in some cases. So we'd want to look into that to see maybe where to start, and see how we can make that work better, more quicker, perhaps.
The Hawaii Board on Geographic Names, right now we're meeting quarterly. We used to meet monthly, but now we're meeting quarterly, so we don't review names as often. But in general, what we did early on was look at all the names on the quad maps, the USGS quad maps, and look at the spellings of them, primarily the spelling. So adding Okina and Kahako where it was appropriate, and where when the Hawaii Board made decisions on names, we sent them up to the US Board.
Right.
And if they approve them, then they become part of the GNIS, and then all federal agencies are required to use those names. So in many cases, on many maps, you'll see geographic features with Kahako and Okina. For the Hawaii Board, if we can't verify the spelling because we don't know the history of the place, and our sources aren't clear about the origin of the name, we'll generally leave the name for consideration later, or to wait to see if some evidence or something comes up later to support a spelling change. We have also done name changes. So for example, Loihi off of the Big Island, and I shouldn't even call it the Big Island because the official name is the Island of Hawaii. But Loihi was renamed, I can't even remember the name now, just based on Old Mele. And some, well, anyway, so yes, there are names now that you'll see for streams, for example, that some are in English and some are, maybe in Olelo, Hawaii. But the Hawaii Board is not making a practice of just changing the name. It's really based on research, what the common usage is, and sort of the relationship of the place, or in the case of water bodies, the water body to the place. But yeah, if it does make it up to the US board and they approve it, it does become part of the GNIS, and then you'll see it eventually trickle into new maps as they're made.
Yeah, that's true. It should show up on our National Map Viewer pretty quickly, which is kind of an online thing that lets you turn on different layers and see the data as it is now. It would also start to show up on the topo maps when they're generated, hopefully relatively quickly, once it's been approved and now into the GNIS. But you're right, it is exacting and a kind of precise process to do that. And I've sat in some of the meetings here in California. I'm learning what you already know, Arthur, on all the steps that you go through there.
So a name might be in English have the North Branch and South Branch, and in Hawaiian it might have two different names for the two branches, something like that. Is that I've just seen some streams that seem to have every single branch as the same name.
Yeah, it really depends on what's in the GNIS, and in the case of streams in Hawaii, whether the board has made a decision or not, because there is only one name, one primary name in the GNIS, and that's the name that federal agencies are required to use. There may be variant names, older names or equivalent names, but those are not the primary names. The primary names is what you'll see on USGS maps or on many interactive maps. But yeah, it's confusing. Can be.
Yeah, you can search your database too. There's this domestic name search, and you can see all the variant names that Arthur said too, and all the other attributes tied to the name.
Thank you. So your hydro is determined by elevation. So I would think that would be problematic for irrigation ditches. Do you cover them?
Yes, we do have canals in there too. And they will have to show a flow direction one way or the other. They can't be flat too. If it's bidirectional, and it could change directions too. And so it should be able to convey water either, obviously downhill or side to side if it's flat. So that's been an issue even though the old NHC did not have elevations in the data, it was still an issue just trying to show how it flows, what direction does it go in, things like that. And so yes, it is tough, but we're still going to have those in there.
My last question. We spoke in San Diego over a year ago, and I was asking about intermittent streams, and you were saying that instead of perennial versus intermittent, that there would be some kind of measure of likelihood of water, or has that been, could you elaborate on that, and how far has that progressed?
Okay, well, it's still not on yet. Okay, we'll cut right to the chase there, but it's not far away. It should be around the beginning of the next fiscal year, or in a month or so from now, month or two. And what that is, it's a modeled score or value that is, for example, provides the likelihood or the number of days where water may be expected with an error range. So, for example, if the modeling has determined that a stream has water a lot of the time, it may say, okay, it's expected to have water 200 out of 365 days a year, within an error range of plus or minus 30 days, something like that. And so we are definitely not going to be continuing with the older classifications as those, of course, were derived from the old topo maps. We had the old topo maps starting in the early 1900s, the mid 1900s, and at first they just had perennial and intermittent, and later on ephemeral was added to that. And so it's sort of trying to get away from now the old map-based hydro, getting into hydro based on hopefully the true conditions or other influences on that, right? Such as the gauge measurements, weather inputs, and things like that. I don't know all the inputs though to the modeling, so that's a good question. But that's what we're going to be coming up with. It will be a table that will be made available that people will have to then link it to the line work, and that's in the first iteration. Shortly thereafter, say within, I would guess, a year or two, or that may change too, but the intent is to have that built into the system so you don't have to link anything. So yeah, I've got a lot of questions on that. I look forward to seeing what it looks like though when it's out.
Thank you. That's all my questions.
Thank you.
Joe, I have a question
Mhm.
on the 2020 3DEP
Mhm.
funding proposal. It was the Office of Planning and then a whole bunch of federal agencies. So is there an expectation for how much in terms of, is it like a 50-50 match for USGS versus other funding sources, or is there, because our contribution in that case was very tiny compared to what it ended up being. I think we put in 50,000 and it ended up being over $1 million
Yeah.
total funding. So is there, what kind of funding should we be looking for from the state and maybe the counties if they're interested in this DCA?
So technically USGS could not put in more than 50% towards a project, but that's just by ourselves. So if it's $1 million project, we could have 500,000, and other non-federal sources would provide the other hypothetical 500,000 to match that. And however, if there are other sources of funds in there, that makes it easier for any other organization to come along to provide the remainder that's needed, especially when it comes to federal dollars. So if USGS had, say, 50%, like we mentioned, and another federal agency had 20, well, then we're only looking for 30. So whether it be the state of Hawaii or the state plus a county or plus an NGO or other groups could easily make that 30 up, or I shouldn't say easily, but it wouldn't have to be the 50. So, and so yeah, a lot of cases there are multiple agencies that that work together on this. We had a lot of help from other feds, kind of depending on the region though. NOAA put some funding in. Some areas they collected it themselves. They got a couple of the territories a few years ago by themselves. NOAA did. Here in the mainland, we had a lot of help from FEMA in California. USGS will always put in whatever we can. And but for example, FEMA puts in most of the money for a region. We may top it off here, but then that gives us more money to put into a different project. So that's kind of how it works.
Okay.
So
Yeah,
we're trying to emphasize though that there's no set thing where, it's like, oh, well, this didn't work out. They didn't have quite enough. We can, we're happy to work with folks on stuff. And also if we plan a bit together before the DCA project submission goes in, that helps us see where everybody is and look for other funding. So if we're talking about doing a big project, and I could say, okay, well, the state is interested and they have, about this, and we have about that. What other agencies can we check with? and that's what the program will look at. Maybe they have another agency like another Fed agency somewhere or some other group that will provide the funding to make up that difference. So.
Okay. Yeah, and that worked out really well for us in 2020. NOAA, I think,
Mhm.
picked up
Yeah,
a big chunk.
it did. We don't mind that at all. That's
Yeah.
great.
And speaking of NOAA, how, with the current environment, how likely is it for NOAA to do something like that again?
Well, I don't know. I haven't talked to Andy over there or heard much about how things are going from their headquarters or in Charleston. I haven't heard anything that said they wouldn't do that.
Okay.
So I would not be surprised to see them involved with this. Things depend by the years and the place, and we've been working a lot. We had worked a lot with FEMA, working a lot with NRCS, and NRCS, by the way, was very active in Hawaii too. And I used to have before working here, I used to work for a state agency, and I did my state mapping, and I did the same job this is now, with my state, looking for federal funding, and we partnered a lot with USGS and NRCS, and FEMA and other groups too. So it's all kind of different, and they'll change a bit over time as well. But yeah, hopefully NOAA's still in there.
Okay. Thanks.
So,
Any other questions? Anybody from the counties, other counties? Might be too late. I'm not sure. It might be too late for this DCA cycle, but maybe it's something that the state and the counties can talk about getting ready for the next cycle, along with you.
certainly, I'd be happy to do that. And we have that first look and reviews in September 12th. But again, it remains open after that. And everything that goes in, we look at, so we know it's there. So it's all good.
Okay. Well, speaking for my agency, we have just a very tiny pot right now that we could put in, so not really significant amount without other partners. But I need to talk to our seaworm folks. I think they were very much involved in NHD, and
Okay.
also maybe to our coastal zone management program folks. They work a lot with NOAA, but maybe there'd be some
That would be great.
funding
We'd love to
possibilities there as well.
chat with you all about that, and look for an area where you may want to apply the LiDAR that's been collected for a watershed or region and see how the 3DHV goes.
So for say LiDAR collections that are going on now that have already started, how can those be incorporated into the 3DHP data set?
You're talking about the LiDAR data, or
Yeah, if they're collecting LiDAR now for a project.
Yeah, the LiDAR that's been collected and accepted by 3DEP could be used as input.
Okay.
So you saw the map I had. Not every, the islands aren't completely covered, but there's still quite a bit overall. And the watersheds, if it's best served by using a smaller watershed like a Huck 10 or 12 instead of a 8, we could look at that too. So yeah, interesting to do that. Happy to chat.
Okay. Well, I appreciate your time, and thank you, everybody. If there's no more questions.
Okay. Well, thank you all very
Thank
much.
you again, Drew.
Okay. And I'll try to see about getting these slides over to you too. Again, I'll have to have them checked like I did
Okay.
before, but practice makes perfect, and
right.
hopefully it won't take too long.
Appreciate it.
Okay.
Okay. Thank you, everybody. Talk
Thanks,
to you soon.
everyone.
Thank you.
Hey,
Thank you.